Good afternoon, students. So, in your previous lecture, we started with the discussion of what is unsupervised learning neural network. There we saw that how neural network can be trained on their own and how they can recognize patterns on their own and can give particular outputs. Then we started with the discussion of what is a deep neural network and how it was different from a normal neural network. Like if a neural network has more than two hidden layers, it was categorized under deep neural network. We also discussed like how deep neural network works and what is the basic difference between the normal neural network and the deep neural network. Then we saw its basic functioning, and then at last we discussed about what is a CNN. And we saw that how CNN is basically used in image recognition process and how it categorizes the images into various blocks and pixels and tries to identify what is in the image and also tries to remove the noise that any image will have. So this is what we did in your previous lectures. So we were discussing about the various layers present in the CNN. We have discussed about the pooling, I guess, or let us start with this thing once again. So we will start with discussion of the architecture of CNN. A convolutional neural network consists of an input and an output layer, as well as multiple hidden layers. The hidden layers of a CNN typically consist of a series of convolutional layers that convolve with a multiplication or other dot product. The activation function is commonly a ReLU layer. What is ReLU? That we will discuss when we will discuss about the example for CNN, and is subsequently followed by additional convolutions such as pooling layers, fully connected layers, and normalization layers, referred to as hidden layers, because their inputs and outputs are masked by the activation function and final compilation. Though the layers are colloquially referred to as convolutions, this is only by convention. Mathematically, it is technically a sliding dot product or cross correlation. Now, let me just show you how basically the CNN looks like. So, over here, they have taken an example of image recognition. Like, suppose we have an image of a car. Okay, this is the input that we are providing to our CNN algorithm. So these are the layers that this image will pass through, or these are the layers present in that algorithm that will be applied to that particular image, and then we will have the output. Now, if you see over here, it has four kind of outputs, or there can be many kind of outputs, out of which it will justify that which category our output belongs to more. Like over here, they have categorized into it can be a car, truck, van, and they have continued up till bicycle. So this is how the whole process goes on, and the various layers present in the CNN is what we are discussing right now. So next, the first layer that we can say basically is called as convolution. When programming a CNN, the input is a tensor with shape. That is number of images cross image height cross image width cross image depth. Now let me just show you example for this also. Now over here they have taken an example, like this is how we consider the image values h cross w cross d, where h is the height, w is the width, and d is the dimension. Over here they have taken an example of 6 cross 6 cross 3 array. The the three value over here actually means that the image consists of three colors. As this is a 6 cross 6 cross 3 array, over here they are considering just the RGB values, that is red, green, and blue values. Now they have yet considered one more example of 4 cross 4 cross 1. One means that the image will consist of just one color, and that will be a grayscale image. So this is how the images are categorized when we talk in context of CNN. Alright, moving on. Then after passing through a convolutional layer, the image becomes abstracted to a feature map, because obviously now we are actually scanning all the layers of that particular image. Actually, not scanning of that particular image, scanning the pixels of that image, so that we can identify that what is that particular object present in the image. With shape, that is again the number of images cross feature map height cross feature map width cross feature map channels. Now what it is, you will understand in more detail when we will consider the example that I was just showing you. A convolutional layer within a neural network should have following attributes: convolutional kernels defined by a width and height. Then we have the number of input channels and output channels. The depth of the convolutional filter must be equal to the number of channels of the input feature map. Now see over here. Now what it is, this is the image that we have. Okay, so it has certain height, width, and depth. In that case, it is actually multiplied with a filter which has f of h cross f of w cross d. And then we get an image, the output image that we get by multiplying these two arrays. Why we call it array? Because here we are considering values of the height, width, and the dimension. So this is something, the input process, the inside the process of hidden layers, which this is something it looks like. Okay. Okay. Then it says convolution layers convolve the input and pass its result to the next layer. This is similar to the response of a neuron in the visual cortex to a specific stimulus. Now we are talking about the CNN, and we considered the image recognition as its main example. So over here, what they are doing is they are actually matching it with the neurons present in the human eye, which is known as the visual cortex, and how our eyes actually perceive certain images, the various lights, and the various colors present around us. So, image recognition is basically we are matching with the eyesight that we have and trying to identify the images with the help of an algorithm. Each convolutional neuron processes data only for its receptive field. Although Fully connected feed-forward neural networks can be used to learn features as well as classify data. It is not practical to apply this architecture to images. A very high number of neurons would be necessary, even in shallow architecture, due to very large input sizes associated with images. Now, if we talk in context of our human eyesight, we can see many kind of images. We have a very wide range through which we can see. But if we talk in context of CNN, the images that this the images that pass through this algorithm can be, we can say that, one image per time, because if there can be more images that can be processed in a certain amount of time, we will need more amount of neurons and obviously more processing and computation time. And there can be a case that the images, the output that we will get through this CNN, in that case, if we will have more neurons, it will not be efficient. So, moving on, a very high number of neurons would be necessary, even in shallow architecture, due to very large input sizes associated with images, where each pixel is a relevant variable for each neuron in the second layer. The convolutional operation brings a solution to this problem as it reduces the number of free parameters, allowing the network to be deeper with fewer parameters. For instance, regardless of image size, tiling regions of size 5 cross 5, each with the same each with the same shared weights, require only 25 learnable parameters. So what they did over here, like earlier they were considering the various parameters like the pixels in the image were categorized based on the various parameters, but now they have just reduced to 5 parameters and they are considering the small pixels of 5 cross 5. So this is how they are trying to make the algorithm more efficient. Next layer that we have is pooling. Convolutional networks may include local or global pooling layers to streamline the underlying computation. Pooling layers reduce the dimensions of data by combining the outputs of neurons cluster at one layer into a single neuron in the next layer. Local pooling combines small clusters, typically 2 cross 2. Global pooling acts on all the neurons of the convolutional layer. So over here they categorize the pooling process into two types, that is local and global. For local, they are considering the clusters, the filters that we will apply to our input image by 2 cross 2, and in case of global, they are considering that we will act directly upon the input of neurons that we will have in the convolutional layer. In addition, pooling may compute a max or an average. Max pooling uses the maximum value for each of a cluster of neurons by the prior layer. Average pooling uses the average value from each of a cluster of neurons at the prior layer. Then we have next layer which says fully connected. Fully connected layers connect each neuron in one layer and every neuron in another layer. It is principle. It is in principle the same as a traditional MLP. The flattened matrix goes through a fully connected layer to classify the images. Now, as I was telling you about the RELU layer, that the images pass through the RELU layer, the RELU is basically known as the receptive field layer. In neural networks, each neuron receives input from some number of locations in the previous layer, as you can see in this diagram. So this is it, convolutional plus the RELU layer that we will have. Then we have the pooling layer, and again we will pass through the convolutional plus RELU and the pooling layer. And after that, we will just pass through the basic network of neurons, that is flattened, fully connected, and softmax. So these are some of the hidden layers that will be present in our CNN algorithm. In fully connected layer, each neuron receives input from every element of the previous layer. We have discussed this point in your MLP. In a convolutional layer, neurons receive input from only a restricted sub-area of the previous layer. Typically, the sub-area is of a square shape. The input area of a neuron is called the receptive field. Repeating this line once again because it is important. The input area of a neuron is called its receptive field. So, in a fully connected layer, the receptive field is the entire previous layer. The sub-area of original input image in the receptive field is increasingly growing as getting deeper in the network architecture. This is due to applying over and over again a convolution which takes into account the value of a specific pixel but also some surrounding pixels. Also, one more thing, students, before I forget, for your mid-sem 2, the syllabus will be till chapter number 5, and right now we are continuing with chapter 5. Okay, so next we have is weights. Each neuron in a neural network computes an output value by applying a specific function to the input values coming from the receptive field in the previous layer. This is something that we just discussed, that the neurons, the input of neurons that we have is considered as the receptive field, and you are aware of what weights are and what is the meaning of weights when we talk in context of a neural network. The function that is applied to the input value is determined by a vector of weights and a bias. Learning in a neural network progresses by making iterative adjustments to these biases and weights. Now, when we were talking in context of MLP, there we talked about a process known as backpropagation, where we were changing the values of the weights and trying to calculate the output. The output was something which we wanted to be according to us. So that is how we were training in case of MLP. When we were talking about RBFN, the back propagation can be there, cannot be there. It just depends upon the type of example or type of data set that we have inputted to our RBFN algorithm. But in case of CNN, there is no such thing as back propagation. We just try to change the values of weights and biases randomly and then calculate the output accordingly. The vector of weights and the biases are called filters and represent particular features of the input. Now, if we talk about the images, now obviously almost everyone uses social media. Whenever we try to upload an image, we certainly think of applying some filter. Now, what does filter do? The filter actually amplifies that particular image, maybe in context of the color, the smoothing of the image, and various other factors. Now, the filters that we apply to our image are nothing but just a matrix of the various weights and biases, and accordingly, it is just applied on our image, and then we get a certain output. So the vector of weights and biases are called filters and represent particular features of the input. A distinguishing feature of CNNs is that many neurons can share the same filter. This reduces memory footprint because a single bias and a single vector of weights are used across all receptive fields sharing the filter, as opposed to each receptive field having its own bias and vector weighting. So that is why once a filter has been applied, after its application is done, then only you can just use another filter. So at a time we can just use one filter on a particular input image. Okay, so now we are done with the various layers present in the CNN. So let us go to its example. Over here, they are saying that the CNN basically is used to categorize the image recognition, image classification, or object detection, right? So, CNN image classification takes an input image, processes it, and classify it under certain categories according to what is there in the image. Computers see an input image as array of pixels and it depends upon the image resolution. Based on the image resolution, it can see H cross W cross D that I told you that it is the height, width and the dimension. So the example is an image of 6 cross 6 cross 3 array of matrix of RGB because 3 refers to the RGB values, and an image of 4 cross 4 cross 1 array of matrix of grayscale image. So this is how a 6 cross 6 cross 3 image will look like because it consists of just 3 colors. This is something, it's matrix that we have considered. Technically, deep learning CNN models to train and test. Each input image will pass through a series of convolutional layers with filters. The filters are also known as the kernels, pooling fully connected layers and apply softmax function to classify an object with probabilistic values between 0 and 1. Now, till now, we were just known of an activation function. In case of normal neural network, then in case of MLP, and also in case of RBFM, we saw that we were just applying the activation function, and activation function was just to varying from a sigmoidal activation function to Gaussian activation function in case of RBFM. But over here, they have uh, introduced a new term that is the softmax function. So when we talk in context of CNN, we will make use of softmax function to classify the objects according to the probabilistic values between 0 and 1. Okay, now next they have considered the image that I was just showing, that it passes through the various layers and it passes through the neurons, and then we will get the output. So the first layer that we have is convolutional layer. Convolution is the first layer to extract features from an input image. Convolution preserves the relationship between the pixels by learning image features using small squares of input data. It is a mathematical operation that takes two inputs, such as image matrix and a filter or kernel. This is also, I explained you that this is how we will consider the input image, and we will apply a filter, which is also known as the kernel, and then we will try to calculate its output. Now, if you see, it has three dimensions, h cross w cross t, and the filter that we will apply to it will also have the three dimensions, which is f of w, f of h, and d. The output that we will be getting will be h minus f of h plus 1, w minus f of w plus 1. Consider a 5 cross 5 whose image pixel values are 0 and 1, and a filter matrix of 3 cross 3 shown below. Now, if you see, this is the image that we have, and this is the filter that we are applying to our image. So, this is the output that we will get. Then the convolution of 5 cross 5 image matrix multiplies with 3 cross 3 filter matrix, which is called the featured map, as output shown below. So when the two, the image matrix and the filter matrix will be multiplied, this is something which we will get, and it is known as the featured map. Convolution of an image with different filters can perform operations such as edge detection, blur, and sharpen by applying the filters. Now, if you make use of some photo editor or something like that, then also you can see these things in your that particular application. That is the edge detection, the blur filter, or the sharpen filter. So next they are just showing, like, if we are applying certain filters to our images, then how the output can be changed. So as you can see, we are applying the identity operation. So identity operation means this is the filter that we will get, and the convolved image will look something like this. Then we have the edge detection. Now, if you can see clearly, so the image remains the same, but now the values are just considering the edge, the edge of that particular animal shown in the image. Then if we talk about sharpen filter or sharpen operation, then this is the matrix that it looks like for sharpen operation, and it will just sharpen the edges of that particular image. Then we have box blur, and they have showed the matrix value, and this is how the output will look like, or the convolved output will look like. Then we have the Gaussian blur, and it is just the matrix that is different, but output is almost similar to the box blur. So these are some of the filters which can be applied to the images. Okay, so next we have is strides. Stride is the number of pixels shift over the input matrix. So you must have studied in your various subjects about the um, two or three shifts, like the right shift or the left shifts. So this is what we are trying to do over here also, that we are trying to shift the pixels by the various stride values. When the stride is 1, then we move the filters to 1 pixel at a time. When the stride is 2, then we move the filters to 2 pixels at a time, and so on. So below they have considered the example of a 2 stride pixel, like over here, as if you can see, they have considered the various colors to make use of how the strides can be considered and how the convolved matrix can be considered as the output. Next we have the padding. Sometimes filter does not fit properly. It fits the, or we can say the input image is not processed properly or according to how we want. We have two options. First, pad the picture with zeros, that is zero padding, so that it fits. Drop that part of image where the filter does not fit. This is called a valid padding, which keeps on valid part of that image. Now, if we talk in context of how we use the photo editors on our images, so you can basically see that there can be certain images on which the filters cannot be applied because maybe the object in that is vertical or horizontal in nature. So in that case, either the image or the editor shows an error that the filter cannot be applied on such kind of image, or what will happen? It will just um, actually ignore that particular area where it cannot objectify that particular object, and rest of the image will be filtered. Next we have is non-linearity, that is RELU. So it stands for rectified linear unit for a non-linear operation. The output is f of x is equal to max of 0, comma x. Now, why ReLU is important? Its purpose is to introduce non-linearity in our cognate, since the real-world data would want our cognate to learn would be non-negative linear values. So we can say that we have to apply certain activation function or certain softnet function when we talk in context of CNN to get our output. Next we have is the pooling layer. Pooling layers section would reduce the number of parameters when the images are too large. Spatial pooling, also called as subsampling or downsampling, which reduces the dimensionality of each map that retains important information. So if you see with every layer, there is something which is happening, and we are trying to make our image more optimized. Okay, so this is something that we will discuss in your next lecture. Today we have discussed about today we discussed about what is CNN, the various layers of CNN, its architecture, and we also considered an example that what is uh, that particular thing that we consider for CNN to be justified in case of images, and how the various filters can be applied on those inputs, and how the convolved output is considered. Anyone having any doubt, you can ask me. Alright, so let's move to your attendance. Class TC1 67,
Yes, ma'am. 67.
roll number 9, 12, 19,
Yes, ma'am.
47, 63, 67,
Yes, ma'am.
69, 73.
Present, ma'am.
Okay, then 79.
77, ma'am, present.
Okay, roll number 80, 85,
Yes, ma'am. 85.
86, 100, 108, 112.
Yes, ma'am.
Okay, 113, 119,
Yes, ma'am. 119.
127, 129, 130,
Yes, ma'am.
135, 136, 164, 190. Then class TC2, 18 series 9, 18 series 9, Kayur, 17 series 7, 11, 29,
Ma'am, 18 series is present.
18 series 9 is present, yes. Okay, 7, 11, 29, Abhishek, 58, 68, 71, 75, 78, 84, 88, 89, 96, 97, 103, 115, 117, 118, 133, 173. Class TC3 roll number 4, 40, 172, 182, 18 series 1, 18 series 12. Okay, students, thank you.